topic is development of lateral surface of the solids. This is directly related to the sheet metal work that you did in the last semester, that is in the workshop. In the workshop you were doing, you did pin smithing, right? There you have drawn a diagram. So how much sheet we have to take? A rectangular sheet we have cut from the bigger sheet. Let's say you made a rectangular sheet. For rectangular, how much sheet we have taken? A rectangular sheet of some 150 mm by 110 mm rectangular sheet you have taken, and you have drawn some lines on it, and you have cut it accordingly, and small pieces are removed, and then you just bend it using the stakes and maggot and all that, right? To get that rectangular plate. That means we will be in development of lateral surfaces. You will be finding the area of the sheet required to make that particular solid. So it is directly related to that. There are so many applications. Applications have been narrated there and explained there. Okay, whatever bus bodies, cylinders, containers, all these are comes under that. This sheet metal work, you have things with yours. Let me take the example. To put it simple, it's a simple topic. Even in terms of examinations, let's say, it's a scoring topic, very simple topic. You can easily understand, you can easily depict it on the drawing. So we will add 100% on the top. Now, this is cylinder. This is cylinder. In order to make this, we need this much sheet. In order to make this, and we will be joining these two. There is some soldering, all that. We didn't do that in the workshop, but there are so many techniques to join it. When we have done this, folded a little bit, and we have attached them so that they do not get detached. Right? So this is the way. So in order to make this lateral surface is this, we need this much sheet. That means we cut along one of its generators and we lay it on the flat face like this. So this is the sheet required to make this cylinder. Under this, we will be dealing with the finding of the sheet or developing the lateral, because it is developing the lateral surfaces. So development of lateral surfaces will be going for so many things. Let's say full solids, cut solids, and that also will be there. Already we have discussed the sections of solids. So full solids, cut solids, or sometimes solids with some holes. Holes may be of circular holes, hexagonal holes, square holes, whatever it is. All this will be doing. Unit 4, and only one topic is there in this. The other topic has been excluded even for your senior. And before that it was there, and slowly there's because student friendly syllabus. So they are excluding important topics from the syllabus. That is another story. So let us go for it. So how to draw this? You have to draw the projection. So keep this in mind and let us go for it. And there are 4 methods of development. One is stretched out parallel line method. Stretched out parallel line method. Continue to write this. When I am writing here, it is simple. You can listen and write simultaneously. That is the purpose of sitting here and make running notes. I do not give any dictations here. Stretched out parallel line method. Second one is radial line development method. And third one is triangulation method. And fourth one is approximation method. And under this also, these two have been never there in our syllabus of this topic, right? Eventually, only these two are there. And broadly, we will be using this to develop prisms and cylinders, both full cylinders, full solids, and as well as cut solids. And this one is for cones and pyramids. So as we discuss the method or as we discuss the specific problem, you will come to know why this naming stretched out parallel line method and radial line method. Depending upon the step-by-step procedure, these names have been given. So this would be simple. As we discussed the cylinder, so we will be drawing the projection first because it may be full solid or touch solid. So let's say cylinder is standing like this. Always this goes according to at least when we consider our syllabus so it's like this. It is simple. This is the development, right? So what is happening is the length of the axis. Length of the axis is becoming one side of the rectangle, and this circumference of the base or top is becoming another side of the rectangle. Rectangle is two sides. One side is directly this is length of the axis, and another side is equal to the circumference of its base. So that goes like this. So obviously, this is coming from here. We are stretching out a line from there, from the top. That means this length is fixed already. This has been stretched out. These two lines, parallel lines. So this axis is coming here with the structure. This is the development. Give some 10 mm or 15 mm gap here and write it. So straight away we got in this. Why that stretched out parallel line? Just after writing the projections, the length of the axis is coming here.